Listen to this. You dial a standard phone number, the call connects, and you are immediately talking to an AI that responds in under a second. No awkward pauses and no robotic menus. Achieving this speed requires dropping the traditional processing pipeline. We are no longer converting your speech to text, generating a text reply, and then converting that text back into synthesized speech. Instead, we stream audio straight from a Twilio phone call directly into OpenAI's real-time API. Twilio handles the telephony network, and OpenAI processes the raw audio in and streams raw audio out. To build this, you need 4 tools: Node.js on your machine, a Twilio voice-enabled phone number, an OpenAI API key, and the ngrok utility. Ngrok creates a secure tunnel to expose your local development server to the public internet. IVR stands for Interactive Voice Response, the traditional automated phone system menus we are all used to. By removing the text translation steps in the middle of that pipeline, we strip out hundreds of milliseconds of lag. That direct audio-to-audio connection turns a rigid phone menu into a fluid conversational agent. Step 1 is setting up the environment. Open your terminal, initialize a new Node project, and install 3 specific packages: Fastify for our web server, WS for WebSocket support, and .env to manage our environment variables. A WebSocket is a communications protocol that keeps a continuous two-way connection open between the client and server. Next, create a file named .env in your project folder. This is where you will paste your OpenAI API key, so it remains secure and out of your main codebase. Before you move on, check your OpenAI dashboard. The real-time API requires a funded account with a positive credit balance. If you try to use a free tier key, the connection will drop silently without throwing a helpful error code. Verifying your account balance and locking down your API keys now ensures you won't spend hours debugging empty audio streams later. With the prep work done, we can write the server logic. In your main JavaScript file, we start by defining the system message. This is a block of text sent to OpenAI when the call connects, telling the AI how to behave, what tone to use, and what topics it should avoid. Next, we set up a server endpoint called /incomingCall. When a user dials your number, Twilio pings this route. We reply with TWIML, Twilio's markup language, instructing Twilio to answer the phone and immediately open a bidirectional media stream back to our server. Here's a critical technical hurdle: audio format mismatch. Twilio uses 8 kHz MULA compression, but OpenAI requires 16 kHz PCM. Our note server acts as a proxy, continuously decoding, upsampling, and passing audio packets to OpenAI, then reversing the process for the AI's reply. Handling that continuous two-way audio translation in milliseconds is the exact mechanism that lets 50-year-old telecom infrastructure communicate with a modern multimodal AI. Step 3 is making your server public. Start your Node application in the terminal, and then open a second terminal window to launch ngrok, pointing it at your local port. Ngrok generates a secure, randomized URL that routes traffic from the open internet directly to your laptop. Find that forwarding address in the terminal output and copy it to your clipboard. Now log in to your Twilio console, navigate to your active phone numbers, select the one you want to use, and scroll down to the voice configuration settings. Look at the field labeled "A call comes in." Paste your ngrok URL here, and then manually type /incomingCall at the end of it. If you miss that specific path, Twilio will hit the wrong endpoint, and the incoming call will immediately fail. Saving that configuration bridges the final gap. Your local JavaScript file is now a live, globally accessible telephony endpoint, waiting for its first call. Now we test the system. Dial your Twilio phone number from your cell phone. As it rings, watch your terminal window. You will see the WebSocket connection open, followed by a stream of data packets as you start speaking. If you notice the AI interrupting you or talking over your sentences, you need to adjust the voice activity detection settings. By increasing the silence detection buffer in your session configuration, the model waits a fraction of a second longer to make sure you are actually done speaking. This diagram breaks down your operational costs per call. You pay Twilio a fixed rate for every minute the phone line is open. On top of that, OpenAI charges a variable rate based on the exact number of audio tokens processed during the conversation. A token is simply the basic unit of data, like a short snippet of sound, that the AI reads and generates. Building the proxy yourself is the best way to understand the architecture, but when you are ready to scale, look into PipeCat. PipeCat is an open-source framework designed specifically for voice AI that handles the audio buffers automatically, adds custom tool calling, like fetching live CRM data. By mastering this manual WebSockets to telephony proxy, you now understand exactly how the raw audio moves through the network. That gives you the technical foundation required to build, debug, and scale enterprise-grade voice applications.